Hi, welcome back to my channel. So this is the continuation for the lexical tokens, which I have done part 1. And if anyone didn't see that particular thing, I'll be giving the a link in the description channel. Just go through that first see the lexical tokens part 1 and then come to the part 2. So now in the part 1 we have discussed like various lexical tokens like white space, comments, strings, constants and all. So in this particular part 2 we will be discussing about some topics which are not there. So if you see the before things, most of them are covered in C also. So some of the things now that we are discussing are purely from Verilog. Okay, so coming to identifiers. So identifier, what is identifier? Identifier is nothing but it is just a name you want to give. For example, we have seen like let us see the program. Okay, we have discussed some example program here. See, in this program this module is named like full adder is. Okay, so if you see the name here, full adder is, this is the identifier. Identifier is nothing but the name that you are giving to some particular yes, particular module, or whenever you write some functions or tasks. Okay, you need to name that particular function or the task. So why is this name important? Because as I already told you, whenever you want to reuse it somewhere, okay, whenever you want to instantiate it or somewhere, whenever you want to create active copy of that particular thing somewhere, how can you do that? If you are having the name of that particular thing, by using that name you can create a copy of that. Is it or not? So that is why identifiers are important for every for every module or for every function, everything. For everything identifiers are important. So when you are using these identifiers, you need to follow some rules. Okay, that means whenever you are naming something, you shouldn't randomly name it. Okay, you need to follow some rules before naming that particular thing. So let us see what are those rules. So firstly, identifier can contain only these particular things, like it could contain 0 to 9 numbers, or A to Z characters like A, B, C, D, so on up to Z, and as well as small characters like uppercase of A to Z and smaller case of lowercase of A to Z. And as well as it could contain two special characters. It could contain only two special characters, which is underscore and dollar symbol. So apart from these two special characters, you shouldn't use the remaining special characters when you are naming something in your Verilog code. Okay, and then the second important rule is, even though you could use all these things, again it is again limited that you shouldn't start your name with either dollar symbol or else a number. That means you shouldn't start your name, you shouldn't start the name of the identifier with number or else a dollar symbol. But you could use these numbers and dollar symbol in the, like in the middle of your name. See, if you see here in this particular program, see, I have used this underscore symbol in middle of my name. But in this way you could use dollar symbol also in middle, but the thing is you shouldn't use it in the starting itself. Okay, that is another thing. And also the identifier shouldn't contain only numbers. That means you shouldn't give just numbers like 1 2 3 4 5 6 7. Like in this way you shouldn't give only numbers, it should contain characters as well as numbers. Okay, and then it shouldn't contain any white spaces. That is what in the starting, in the before part 1 I have told you. Lexical token, like white space is ignored in two cases, doesn't ignore in two cases, like it doesn't ignore in strings, in case of strings. Okay, in the previous class I explained you about in strings the white space is considered as a character. And then in lexical tokens, that means in some special tokens like identifiers. Okay, in identifiers the white space shouldn't be used. That means while you are naming something, when you want to use a space, you could make that space as underscore symbol. That means instead of using the space, you can use the underscore. Okay, but you shouldn't use the white space. Okay, and then keywords cannot be used as identifiers. What does this mean? So basically, in the as far as we have seen the programs, here we have seen some programs and some keywords in that particular programs, like module, end module, input, output, assign. So what are all these? These are keywords in the Verilog. That means you can use them directly. Okay, that means they are already inbuilt in the Verilog directory, and you can use them. Like, those are called keywords. Okay, so those keywords are already inbuilt in the Verilog, and that is why you shouldn't use them as an identifiers. Okay, and then the identifiers are case sensitive. What does this mean? For example, if you are using half adder and half adder, if you see, the name is same for everything, but the only difference is that here H is small character and here the H is uppercase. So now you could give these two names to two different things. Why? Because this is case sensitive. So that is why this is one unique name and this is second unique name. Okay, right? Clear? So this is about identifiers and some of the rules before naming some particular module or some particular function or anything. Okay, so identifiers is nothing but name that you are giving to your particular module or to your particular function, to your particular variable, to your particular anything in your program. When you are naming something, that is nothing but you are using an identifier. Okay, so see here, module. So module name is nothing but this is where you will be using the identifier. Okay, and if you see this program here, module xyz, so this is my identifier. Xyz is my identifier, and these are some of my identifiers. If you see here, these are some of my identifiers. So okay, so if you see here, some are valid and some are invalid, because as I already told you, based on the rules and regulations. So AB $23. Okay, so this is the valid identifier, and AB12, this is also valid. And if you see here, this is also valid because it shouldn't start with only dollar. There is no rule that it shouldn't start with underscore. So this is valid. Why is this invalid? Because here this starts with 2. Okay, and then this is also invalid, and this here, why is this invalid identifier? If you see here, sorry, if you see this, it shouldn't contain only numbers. That is why this is invalid. Okay, when you see here, this is ES at the rate. So at the rate is not the symbol that you are going to use. As I already told you, you can only use underscore and dollar symbol. So that is why this is invalid. And the white space here, that is why this is also invalid. Okay, so this is why you should know how to use the identifier. This is why you should know the rules of, because basically whenever you are going for some interviews and all, there may be, these are some basics, really basics, that no one could even think of. Like okay, this may be the error you doesn't think of, but these are the basics that you need to know. These are the roots for your program. Okay, so this is about thing. For example, even though if you have seen, if you want to make all this invalid to valid, is there any way to do it? Okay, without changing these things, if you want to make this invalid identifiers as valid identifiers, so is there any way to do the such thing? So there is. Those are called as escaped identifiers. Escaped identifiers is nothing but whenever you want to break that rule, like break the rules that are given by the identifier, you can do it by just using a backslash and ending with white space. See, for example, generally, okay, let us see this program. In this, there are lot of errors. Like since it shouldn't start with number, but it has started. So this is invalid. These three are invalid. Okay, now if you doesn't want them to be invalid, then what can you do? You should be giving a backslash at the starting of the identifier name, and you should leave some space, white space. So this is the syntax for escaped identifier. Okay, when you are using this escaped identifier, then you can break the rules that are set by the identifier. Okay, so this is about escaped identifier. right? And then coming to verilog keywords. So in the before I have told you, so what is the meaning of this verilog keywords, what are the verilog keywords and all. Okay, so some of the verilog keywords like assign, case, while, wire, reg, and on, and many of the keywords. Okay, and also one important thing I already told you, they shouldn't be used as an identifiers. So verilog keywords also include compiler directives, system tasks, and functions. Okay, we'll be seeing what are these compiler directives, system tasks, and functions further. Okay, so and also a verilog provides list of reserved keywords. That means there are some keywords, these are some of the keywords in verilog, like these are not all, but some of the keywords, like you'd see always, end. Okay, and if you see here module, see module, and end module, right? See end module, end function. Function also is a keyword, like if you see function. Okay, and then task. Okay, task. Okay, these are some of the keywords, like default is also a keyword. Okay, case. Okay, buffer, begin, assign, initial. Okay, so you'll see many of the, see output is also a keyword, as well as input. Okay, see input, in, out, output. So mostly all of these are keywords. Keywords is nothing but they are already built in the system verilog directive, and you could directly use that here. Okay, so this is all. And also in the before session only I have told you that verilog is supporting four different value levels, like 0, 1, x, and z. So 0 represents false condition or logic 0, 1 represents logic 1 or true condition, x is unknown logic value, and z is high impedance value. Okay, so this is all for today's class. In the next class we will be discussing about like data types, which is very important in verilog. Okay, so this is all for today. If you like my explanation, and if you like to see more sessions on this, please subscribe to my channel. And also follow me on LinkedIn also, where I'll be providing you notes on this particular chapter, like verilog, system verilog, and all. So you could follow my link there. I have given my link in the description box, so you can go check them out there. Okay, thank you.